Have you ever wondered where everything came from? How did something arise from nothing? These are questions that have intrigued and puzzled humans since the dawn of time. They invite us on a journey back to the very beginning, to the birth of the universe itself. Our understanding of the universe has dramatically evolved over time. Once we believed our Milky Way galaxy was all there was. Now, we know the universe is a vast expanse teeming with billions of galaxies. We can trace its history back to its earliest moments, to a time when all that exists was concentrated in an incredibly dense and hot point. This was the stage for the biggest event in history, the Big Bang. The Big Bang wasn't an explosion in the traditional sense, rather, it was an explosion of space itself. From this intense density and temperature, space began to expand. As it did, the universe cooled and the simplest elements formed. These elements, driven by the inexorable force of gravity, began to coalesce, forming the first stars and galaxies. Over time, these galaxies grouped together into clusters and superclusters. Some stars met their end in spectacular supernova explosions. The remnants of these celestial fireworks seeded new generations of stars and made possible the formation of rocky planets. And on at least one such planet, life evolved to a point of consciousness. Life that could look up at the stars and wonder, where did I come from? The more we delve into these cosmic mysteries, the more questions we unearth. The nature of our existence, its origin, its purpose, these are questions that lead us back to the same great enigma. How did the universe and everything in it come to be? And the ultimate question, how did something arise from nothing? This isn't just a question about where everything came from, it's a question about how it all started in the first place. And as we continue our journey back to the beginning, we inch closer to unraveling this mystery. But for now, the origin question remains one of the greatest unsolved puzzles of our time. Our universe started with a bang, the Big Bang. Picture this, an extremely dense and hot state of matter and energy, a point of singularity, and then, in less time than it takes for a light bulb to flicker, an incredibly powerful explosion. This, my friends, is the Big Bang, the birth of our universe. This event wasn't just any ordinary explosion, it was the explosion of space itself, expanding at an unimaginable speed. It was not an explosion in space, but rather an explosion of space. The aftermath of this cosmic detonation was a universe much hotter and denser than it is today. As the universe continued to expand, it began to cool down. You might be wondering, what was the universe made of at this point? The answer is simple, yet profound. The universe was filled with the simplest of elements, hydrogen and helium, with a dash of lithium and beryllium. These elements, in their plasma state, were scattered all over the universe, a cosmic soup of sorts. But the universe was not destined to remain a hot, featureless soup forever. As it continued to expand and cool, the plasma began to form neutral atoms. This process, known as recombination, made the universe transparent for the first time, allowing light to travel freely. While all this might sound like a chaotic, hot mess, it was anything but. The laws of physics were already at work, guiding the evolution of the universe. The seeds for the formation of galaxies and stars were already present in tiny fluctuations in the density of the universe. The Big Bang, therefore, wasn't just an explosion, it was the beginning of everything we know. It set the stage for the formation of galaxies, stars, and planets. It created the conditions for the existence of life itself. From this chaotic beginning, the universe as we know it started to take shape. The Big Bang was not the end, but rather it was just the beginning. It was the first act in the grand cosmic drama that is our universe. Gravity, the great sculptor of the universe, began its work. With the stage set by the Big Bang, it was time for gravity to start shaping the universe as we know it. As the universe expanded and cooled, gravity began pulling matter together, creating the first stars and galaxies. Now imagine this, a vast, expanding universe filled with clouds of hydrogen and helium gas. These gases were not evenly distributed, and in the denser regions, gravity began to pull particles together. As these particles came closer, their collective gravitational pull grew stronger, attracting even more particles. It's a bit like a cosmic snowball effect. This process, known as gravitational collapse, led to the formation of the first stars. These embryonic stars, or protostars, grew in size and density until their cores became hot and dense enough to ignite nuclear fusion, and voila, a star is born. But these newborn stars were not lone rangers in the cosmic wilderness. They were born in clusters within larger clouds of gas and dust. As these clusters grew, they merged with other clusters, forming the first galaxies. These galaxies were the cosmic cradles of star formation, nurturing countless generations of stars. Over time, these galaxies began to clump together, drawn by their mutual gravitational attraction. Some formed loose associations known as groups, which are like small towns in the cosmic landscape. Others came together in larger congregations known as clusters. And the biggest cities of the universe? Those are the superclusters, massive structures containing thousands of galaxies spread over millions of light-years. The formation of these structures is a testament to the power of gravity. But it's also a testament to the universe's inherent tendency towards complexity and structure. From a uniform soup of particles, gravity has crafted a rich tapestry of galaxies, stars, and planets. So the next time you look up at the night sky, remember this: every star, every galaxy, every cluster, and every supercluster you see is a product of gravity's relentless pull. This was the first step in the formation of our cosmic neighborhood. From the death of stars, new life arose. In the grand cosmic theater, every end is but a new beginning. When a star exhausts its nuclear fuel, it dies in a spectacular explosion known as a supernova. These celestial fireworks do more than just paint the cosmos with brilliant streaks of light. They are also the cosmic forges where heavier elements are created. In the heart of these supernovas, under incredible pressure and temperature, simple hydrogen and helium atoms are transformed into heavier elements like carbon, nitrogen, oxygen, and iron. These elements are then cast out into space, sowing the seeds for new generations of stars. But these elements do not only give birth to stars, they also lay the groundwork for the formation of planets. As gravity pulls together these star-forged elements, they begin to coalesce, forming a swirling disk of gas and dust around a newborn star. Over millions of years, these particles of dust and rock collide and merge, gradually forming larger and larger bodies. These are the building blocks of planets, the rocky spheres that orbit around stars. On at least one such planet, something extraordinary happened. In the vast cosmic ocean, a tiny blue dot, our Earth, became a cradle for life. From the simplest single-celled organisms to the vast diversity of life we see today, life evolved, driven by the fundamental forces of the universe. Over billions of years, life on Earth grew more complex and diverse. It developed the ability to harness the energy of the sun, to move, to think, to feel. Eventually, life evolved to the point of consciousness. It began to look up at the stars, to wonder, to question. It began to unravel the mysteries of the universe, to comprehend its own existence, and to contemplate its origins. This story of cosmic evolution is not just the story of stars and galaxies, planets and life. It's our story. We are children of the cosmos, born from stardust, shaped by the forces of the universe. And on this tiny blue dot, life evolved to consciousness and began to wonder about its origins. Today, our universe is a vast expanse of galaxies, stars, and planets. This grand cosmic landscape, once thought to be confined to the Milky Way, now extends beyond our wildest imaginations and encompasses billions of galaxies, each with billions of stars like our sun. In this present universe, we see a complex tapestry woven from the raw materials birthed in the Big Bang. It's a dynamic cosmic stage where galaxies dance and stars flicker in a symphony governed by the laws of physics. Among these laws is the force of gravity, which shapes the universe, pulling matter into galaxies and stars. Mystery also pervades our universe in the form of dark matter and dark energy. These invisible entities, undetectable by our current technologies, make up a whopping 95% of the universe. Dark matter, making up about 27%, helps hold galaxies together, while dark energy, accounting for about 68%, is thought to be responsible for the accelerating expansion of the universe. Within this intricate cosmic web, life as we know it has found a home. On a small rocky planet orbiting a rather average star, life has evolved to a point where it can look up at the sky and wonder about its place in the universe. We, the intelligent and technologically advanced beings on Earth, are a testament to the universe's ability to create complexity out of simplicity. From the elemental simplicity of the early universe, the building blocks of matter have been repeatedly recycled in the cosmic life cycle. Stars have exploded, seeding the universe with heavier elements, which in turn have formed new stars, planets, and eventually, us. But the universe is not done. It continues to evolve, to change. Stars will be born and die, galaxies will collide and merge, and perhaps, somewhere out there, life might be taking root on another planet, starting another chapter in the cosmic story. From the Big Bang to the present day, The universe has been constantly evolving, and it continues to do so. As we stand on our tiny planet and gaze out into the cosmos, we are not just observers but active participants in this grand cosmic dance, a testament to the universe's enduring capacity for change and growth.